There you go. Okay, so I was going to talk about this one. This one says f of x equals x minus 5 divided by x squared minus 25. And the student was asking, why is x equal 5 a vertical asymptote? And the reason why x equals 5 is a vertical asymptote is because x equals 5 is what we call a non-removable discontinuity. So what do we mean by non-removable discontinuity? Well, the x minus 5s are going to divide out, right? If you have your quantity here, once I factor my denominator, I recognize that x minus 5 divides out. So even though the function is written as x squared minus 5 divided by x squared minus 25, that function can actually be simplified to 1 over x plus 5. So you might say, well, why would you not just write x plus 5 then if that gets simplified to that? Well, the reason being is because x minus 5, this expression in the numerator and denominator, even though it gets divided out, it still represents a discontinuity. It represents a whole. So for instance, an easier way to understand this would be like, what about y equals x squared over x? Well, if you simplify that, that just goes to x. Well, let's just look at it this way. If you simplify, that goes to x times x over x, right? Which is really just x. However, that's not just the line y equals x. You just can't graph y equals x and say that's the same thing as y equals x squared. Because what happened is we divided out the x. That's a removable discontinuity. And therefore, what that means is that creates a whole. So if we were to graph this, it would look like this. It's still going to take the shape of y equals x, but x cannot equal 0. So that's what I mean by these discontinuities, because discontinuities are values that are going to make your denominator equal to 0 for the rational function. So even though it can be divided out, what happens when it's divided out, that just means it's a whole. But since the x plus 5 cannot be divided out, that's a non-removable discontinuity, and that's why maybe I wrote that. I think I did write that wrong. I think that was supposed to be a plus. That's a plus. Yeah. That was supposed to be a plus. My bad. Or I wrote it either way. But therefore, the x minus 5, I wasn't looking at this. Sorry, I had to copy a lot of these down from there. Yeah. So x equals 5 is the vertical asymptote. Now, again, some people might be confused and saying, well, wait a minute. I'm confused here because obviously you're just changing numbers. The x plus 5 is actually divided out. How is the expression x minus 5 in the denominator, but the vertical asymptote is x is equal to 5? Well, again, it's a discontinuity because 5 or negative 5 is the value that makes the denominator 0, right? When you plug in 5 in for x, that's going to make your denominator 0. So the easy way to identify the discontinuities, even before you simplify it, is just set your denominator equal to 0 and solve, right? So if I had x minus 5 times x plus 5 equal to 0, then I could say x equal to 5 and x is equal to negative 5. And I don't know what I was writing there. Okay.